Okay, we've got a couple of circle theorems here. It won't necessarily be one, might be using a couple. Now, I haven't got a lot of room here, unfortunately. And there's a couple of ways of doing this first one. We've got to find the angle BCD, which is this angle here. Okay, could do it because we've got a diameter here. Okay, we could do it by saying, well, that's 90, and working out the other angles. This one here is 36, and this here is 48, and that would therefore be 66, and so therefore this one up here would be 24, and then add them up. That would be perfectly acceptable. Okay, or we could just find the 48, 66 and 54 make 120, and then we've got a cyclic quadrilateral. If I do that in a different colour, cyclic quadrilateral here, where the opposite angles, okay, add up to 180, don't they? So either of those would be absolutely fine. In fact, I think I'm going to do the cyclic quadrilateral. So I'm going to say that, where are we? What colour am I? There we go. So AOB equals 48. And that's just angles on a straight line, add to 180, so straight line. I've not got a lot of room, so you'd have more room, obviously. And then I'm going to say OAD equals 66, and you're going to say it's an isosceles triangle. Now, actually, if you didn't spot the isosceles triangle, it's because that's a radius. Actually, I'll do it in a different colour. We've got that's a radius there, and that's a radius there, which makes it an isosceles triangle. So there you go, isosceles triangle. And then I'm going to say you've got, what is it, BCD, which is what we want, equals 180, subtract 54, subtract 66, which equals 60. And that's because we've got a cyclic quadrilateral. The opposite angles, and I've run out of room, but you will need to write the opposite angles sum to 180. Okay, so there you go, there's the first one. Yeah, like I say, there's a couple of ways of doing that. I've chosen one, but either way would be absolutely fine. There'll be alternative solutions in the answer scheme. Now this one, again, we look like we've got some sort of cyclic quadrilateral here. Here's my cyclic quadrilateral. Okay, we've got that there. Now what angle? RSU, that's this angle here. Hold on, I'll do it in blue. That's this angle here. Okay, now actually, whilst this what is it, SRQ might look like an isosceles triangle, it really isn't an isosceles triangle. Just because it looks like one doesn't mean it is one. Alright, we're going to have to do some calculating here. So what I'm going to do is I'm going to use cyclic quadrilateral to find SRQ equals, so that's this angle here. Right, and that I'm going to say is 104, and that's cyclic quadrilateral as well. Quadrilateral, alright, opposite angles add to 180, again, space at a premium for me. Now I've got that, I can work that angle out. So RQS equals, what's that, 43, and that's just triangle adds to 180, triangle 180, again, write a proper sentence. I don't have room or neat enough handwriting. And then the last one, we've got RSU, which is the one we're looking for there. RSU also equals 43, and you need to use the property alternate segment. Right, segment, spelled exceptionally badly. Right, in fact, I might, that's so bad, I'm going to do that again. Right, so we get segment, that's better, look at that. Now then, the alternate segment part I will do in green, or actually I'll do it in, here we go, we've got tangent there, and we've got this here. Alright, so the alternate segment, that part there, that angle there, is the same as that angle there. Alright, but you've got to learn these circle theorems. There are a few to learn, what, 4 or 5. You've got to learn their names, unfortunately, but you've got to learn the properties. And when you look on a mark scheme, they have certain words that are underlined, all right, and you must include them in your answer, otherwise you don't get the marks, which seems harsh, but actually that's the property they're looking for.